Hello everybody, this is Michael. In this video, we will talk about the system target for FPGA driver I2C EEPROM. So since we driver one I2C EEPROM, we need one I2C EEPROM module. Okay, we use this module for our test. This module is one AT24C02 EEPROM. Okay, so we need one FPGA board, which is this we design for our lessons. Okay, we will use this FPGA board to write the data 55 into the EEPROM. And then we will read it out. After we read it out, we will compare the write data and the read data to see whether they can match each other or not. So if it can match, we will blink or light the LED on the board. Okay. So this is our simple tested target for our FPGA driver I2C EEPROM lessons. Okay, so before we continue the lessons, we need to take a look this chip. Okay, so here this is the data sheet for this chip. So this is EEPROM. EEPROM chip is here. It is a EEPROM. Okay. The first things we need to pay attention is this one. Okay. So the power supply VCC is from 2.7 to 5.5 watt. Okay, 2.7 to 5.5 watt. So which means you can connect the pin to the 3.3 watt or 5 watt on your board. Okay, so this is the first things we need to pay attention. Second, let's take a look at the pin config. Okay, the pin config. The first pin will be VCC, is a power supply voltage. Okay, the second pin is ground. The third pin is clock for I2C. SCL is serial clock input. It's an input signal. Okay, it's generated from the FPGA board. So it's I2C clock. This one is I2C data. It's I2C data. It's input and output signal. Input and output signal. The rest of the pins are the NC pin. Okay, NC pin is no connector. Okay. So actually for the chip is 8 pin. Take a look here. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 pin. Okay. The first one is VCC. Second one is NC. This one is clock. This one is NC. NC. This one is state. This one NC and ground. Actually, we just need the power, ground, and clock and data. Okay, so this is the second thing we need to notice. The third thing, let's take a look at the memory organization. Okay, so we are using this chip. We are using this chip. Is this one? We are using this chip. It is 32 page. It is 32 page. It's 8 bytes each. Okay, 8 byte for each page is totally 32 page. Okay, it's 2K. Okay, it's 2K bit data. Okay. Next things, let's take a look at the clock frequency. Okay, so this is clock frequency. It's maximum. The maximum is 400 kHz. You will notice here there is no minimum. Okay, there is no minimum. So we can try it like 1 kHz, something like this. Next things is the timing. Okay. Next things is the timing diagrams. So this is bus timing, write cycle timing, and for the write cycle timing, we needed to pay attention to this one. The write cycle timing is the time from a valid stop condition of a write sequence to the end of the internal clean and write cycle. It means we need to do some delay. We need to do some delay before we write a new byte. Okay, we need to delay. Okay, after we write some data, before we start a new write processing, we need this delay to let the chip finish the writing inside the chip. Okay, so this is data validity, and we need to change. We needed to change the data in the middle of the clock, low level clock. Okay, we need to change the data in the middle of the low level clock and keep the data stable at the high level. Okay, we need on the high level we need to keep the data stable. Okay, next this is defined for the start B, stop B, and the acknowledge B. Okay, so it exactly match the I2C protocol. We will discuss it later. Okay, this is device address. This is very important. Okay, this is the protocol for the byte writing. So it tells us how to write 1 byte into the EEPROM. Okay, this is the write data protocol. This is page write. This is for 1 byte write. This is for 1 page write. Okay, and this is for read. This is for the current address read. And this is for random read. Okay. The 2 write and the 2 read. The 2 read is the base for our driver. I2C EEPROM. Okay, is the rules we needed to drive the EEPROM according to this protocol. Okay. Okay, this is the sequential read. Okay, for this data sheet, so that's it, and we will go back to see. We will come back to see the detail of the information, and then we will coding the where we will program the FPGA to drive the EEPROM according to the data sheet. Okay, so that's it. So this is our target system target for the FPGA driver I2C EEPROM. And I'm Michael, and see you next time.